Okay, yeah. And I've also started recording, so welcome people to the Python introduction course. So before we get started, this is kind of an interactive demonstration, or at least it's supposed to be. So I've posted the link in chat, and I will do it again. And the aim is that you clone this repository or just download the examples from it. And that way you will be able to follow along and run them on your own computer. You will need the Python interpreter to be installed on your system though, so make sure that you have that. Okay, all that said, we can get started. So this right. So this course is intended as a general introduction to Python. I'm not assuming any previous knowledge of Python. However, I am assuming that you are familiar with programming in general. So in C, C++, Java, JavaScript, Haskell, whatever. So I will be going a bit quickly over the basics. I hope you don't mind. As a reminder, also, this presentation is recorded and I will be sharing the recordings later. So if there's any part of it that you don't understand, you can watch it again later. It's not intended to turn you into a master immediately, but it's more of a starting point. And it will be, and the intention is that we will follow up with a session about using Python for testing, using board form and Python unit tests. And that will build up on what we are going to do here today. So yeah, once again, I do expect active participation, so download the examples listed here. So basically, how this will go is a bit like this.
Let's start with these operation programs first. This makes me okay. Let's do something a little more fun. How about Jiu-Jitsu? I'm going to learn Jiu-Jitsu. Oh shit. Mikey, I think he likes it. So, oh yes. Show me.
Right. So that's about how I expect this to go. So yeah, but if it's if you don't happen to be plugged into the matrix right now, don't worry, you will be able to follow along just fine. Okay, so what is Python? First of all, Python is an interpreted language. That means it's not a compiled language like C or C++ or Java. So there is no separate compilation step, and that means that everything is evaluated immediately when Python sees it for the first time. It can also create fun scenarios, like you can have syntax errors in your code, and your code will load just fine until that particular function is executed that has a syntax error. So yeah, it's also very useful for prototyping because you can just type in some Python code and see the results immediately. So that's quite useful. The standard library of Python is quite okay, but you can add lots more libraries using the pip command, which is kind of like the node package manager for JavaScript. So you can add loads more functionality very easily to Python. So there are lots of libraries for things like user interfaces, or for parsing specific formats, or for loads of other functionality that is not part of the core. One of the major differences between Python and other languages is there are no brackets. So in C, C++, Java, JavaScript, all sorts of other languages, brackets are used to denote different blocks of code. And Python just uses indentation for this, which means basically just white space, steps or spaces. Another important point is Unicode is baked into Python. That means all Python scripts are Unicode. You can write, you can write your Python itself in Unicode, and it does mean that you have to be careful when reading or writing files and sockets, because often you will be reading byte arrays and not strings. So you have to be careful when mixing those in Python. Right. With all that said, the rest of the course will just consist of a couple of example programs. So that's the ones that I've linked before. So these will go from simple hello world with some explanations to basic mathematics and print formatting, to calling external processes, to going over the various containers available in Python, and the if, when, while, for loops, list comprehensions, classes, and finally how to call a web API from Python, which I imagine will be quite useful. Okay. Are there any questions so far?
Yeah, where are the examples that we want to download from your repo?
Yes, so I'll paste it again into the chat. Yeah, so if you go to my repo here, so just clone it with SSH or HTTPS, or you can also just download the files as a zip file and extract that, and then you will also have the examples. So there's multiple ways to do it.
Thanks.
Yeah. So these are the examples that we will be going over in just a second here. So let's start with the very first one, a Hello World program in Python. So Hello World is often used when learning new programming languages as a basic demonstration of what the language looks like. A Hello World program is just supposed to print the text Hello World to the computer console. And this is what that looks like in Python. So let's take it from the top. I've added this line here. This is known as a shebang line, and it lets various environments know that this file is a Python file and can be executed using the command Python free. Then we have some documentation. So these are all various kinds of comments. This kind of comment is called a docstring. We will be learning more about it later. And these are regular Python comments. So all of them are basically ignored by the interpreter. And they serve only as documentation for the people that are reading the code. So for instance, yeah, I've written this comment to remind me to tell you how comments work, and the multi-line comments actually doc strings here above. Yeah, and so Python actually keeps this kind of documentation, the doc string, it keeps it internally and can use it as documentation that can be queried later. So it can be quite useful. So the actual code in this example is just a single line, print hello world. So let's run this code. So how do we do that? So we take a console. So I have a console here. And we can just invoke Python directly with our file. So intro1 hello world.py, and you should see hello world. So as a reminder, I'd like for you to follow along here and try this in your own console. And don't worry, the coming examples will be a lot more complicated. So it might feel a bit pointless right now, but it'll be more interesting later. So yeah, I can run it this way. What I can also do in Linux is run it like this. Because of the shebang line, so the first line will tell bash that it should execute it using the Python free command. So that means I can just execute it like this. Right, and there is a third thing we can do, and that is to use the Python interpreter directly. So if you just start Python free, the command, without any arguments, then it starts the interpreter where you can just enter Python code and it will execute the Python code immediately. So that is quite useful. One of the things that we can do is we can just copy our code and paste it directly into the Python interpreter, and it will work the same way as if it was executing the script. So that is also a very useful tool for debugging Python, for trying out certain things in Python. So if you don't know what the correct syntax is, just open the interpreter and try something. So that's quite useful. For instance, if we want to print something else, if we want to print hello attendees, then we can do it that way. So yeah, this is fairly straightforward, I hope. It's definitely, if you know other programming languages, this shouldn't give you any trouble. So let's move on to the next example. This is another hello world, except here I've rewritten it a bit to put the program inside a function. So the problem with the first example really is this code is always executed, and you can't really do much with it. So you can't really call you can't really call import it from another module and then run it as you want. You have to run everything in the script all the time. But if you put it in a function like this, then you can export that function to other modules, and they can then make use of the function. So actually, the convention in Python is to always write all of your code inside functions like this. So this file is actually identical to the first one in the effects. So what we will do here is the Python interpreter will see, we've defined a function, and then it will skip ahead, and then it sees here the invocation, and then it says, okay, I should call this function. So I should go back into the code to where the function was defined, and then execute this code that is below the function here. So here we can also see the Python block. So block statements. So normally in a lot of languages like C, you would have a block defined using these kind of angle brackets. So in Python, you just use white space. That means if I write a code like this, Python will consider it a syntax error. So you can't do this. So I can show that here. So if I try this, Python says indentation error expected an indented block. So after a function definition, Python expects you to indent the code that's part of the actual function. And so I can write more lines here. And all of these lines that I write that are indented are part of the function. And if I write a line here, then this line is no longer part of the function because it has a different indentation. So that is something very important to realize about Python. So if I execute this, then you see we have it first prints world, then prints hello world, and then prints hello. So what happens is Python encounters the function definition and remembers it. It doesn't execute it yet. Then it encounters the print statement and it executes that immediately. And then it sees, we call the function main, and so we should execute everything that is part of the function. So that's these two statements. So yeah, so feel free to experiment with this a bit in your own time if you like. So I got a question in the chat, which I'll just read right now. So yeah, how to write several commands in the shell all at once. You can just copy and paste multiple lines in the Python interpreter like this. So if you have the Python interpreter, you can just, and let me show it a bit more clearly. I can copy and I can paste in the interpreter like this. And now that I've pasted this in the interpreter, I can call the main function as many times as I like this. So that's also quite useful. Right. Yeah, so are there any further questions? So Moran, I hope that answers your question. Okay, I assume that that's clear for everyone. So let's do some more interesting stuff. Basic mathematics. That's always quite useful. So in this example, I am just playing with a couple of numbers in Python. So we have a variable which we call a, and we assign the value 2 to it. So Python has dynamic typing like most scripting languages. That means you don't have to declare that Python is of type int. No, it's just implied automatically. And if I were to write Python a is 2.5, then the Python interpreter would automatically understand that a is of type float in this case. So Python does have types, but they are all very implicit. You almost never have to specify them. Okay, so I have two variables here, a and b. One I give the value 2, and the variable b gives a value of 3. And then we can just add them together, a plus b. So we add the value of a and the value of b together, and we put them in a separate variable called c. And the value that's stored in there will be 5, because 2 plus 3 equals 5. Like this, we can also do a couple of other operations, like this is how you raise something to the power in Python. So here we raise basically 2. to the value to the third power. So that's 8. And then we add 3 to it, and so d becomes 11, or the value of d becomes 11. Division in Python tends to result in floating point value even if the original values were integers. So that's something else that changed from Python 2 to Python 3. So if you are using an old version of Python, that might look different. But yeah, so if we execute this example here, so we can see that E, so B over A, is 1.5, right? We can also use explicit integer division in Python. So you use, this is a syntax for that. So it's 2 forward slashes. And then we see if you do that, then the result becomes 1. So 3 divided by 2 is 1.5 with normal division and 1 by integer division. Yeah. And then we come to these print statements. So this is another form of the print statement. So you can just print variables directly. So print A will just print the value 2. And you can print multiple things by separating them with commas. So you can add anything you like here. So that's one way to, that's just another way to use a print statement. And as before, we've wrapped all of this in a function. So, yeah, we can import it more easily and reuse that code more easily. Okay. Moving on, we have some more complicated mathematics. So for this, we are going to import a library from the standard library. So this is something new. So if you need additional functionality that is not in the base language itself, so some functions from the standard library, then you need to use the import statement to get them. So in this case, we are going to import the math library from the standard library, which includes a couple of neat functions for doing mathematics, like sine function, cosine function, tangent function, square root function, logarithm function, greatest common division denominator function. So we can use those to do all kinds of interesting mathematical operations. So if we want to calculate what the sine is of 1.5 times pi, then this is how you would do it. We imported math. So math.sin means the sin function, which is defined in the math library. And likewise, math.pi means this pi constant is defined in the math library. So the Python interpreter, when it sees this expression, it will look in the math library that was imported to find the definition of pi. Yeah, here I'm also doing something special. So I am using the %f specifier here to say print me this number as a floating point number. So this is a syntax that is very similar to the printf syntax of C, if you are familiar with that. So you can use that in Python as well. And what you do is you use this syntax, and then you use a percentage sign, and then you use the arguments. I can also use printf specifiers here. Like I can say %2.2f, so it will only print 2 numbers behind the comma or the decimal dot. and things like that. So and you can use a format like this. So it will pad it with zeros until it's 4 wide, things like that. So you can do all kinds of interesting things with these formats. Pretty much the same formats are supported that are supported in the Bash and C printf functions. So that's can be quite cool to play around with. So moving on, I have here also calculated the cosine of 1/4 times pi. And then I'm printing that. And here I'm doing something different. Instead of using the percentage sign, I am using these these angle brackets and the format function. So this basically does the same thing. The format function looks through the string and replaces the angle brackets with its argument. So this is just another way of formatting strings in Python. You can see another example of that here. So here, what I'm doing is I have 2 expressions within angle brackets here. So 2 things will be substituted in the string. The interesting part is I've switched the arguments around actually. So I've written it so that the second expression here will be printed first, and the first expression will be printed second. So it will be printed here. And you can do that with the format. So that's one example in which it is actually a bit more powerful than the printf syntax. So you can also just repeat them multiple times if you like. You can mix and match them better, and so on. Another nice thing about the format function, one last thing that I wanted to share is that you can use names. So instead of writing 0 here, so you can do that. You can write the greatest common denominator of 60 and 40 is this expression. Instead, you can write GCD, for instance. And then here in the format function, we can say GCD is this thing. So that's another very useful thing, because if you have a complicated string where you want to format many different variables in there in different ways, then it's very easy to get lost and make a mistake between number 12 and number 13, for instance. So you can avoid that by actually naming the thing that you are substituting. This is very useful. So let's execute this baby and see what it gives. By the way, if you already predict what the output is going to be, then give yourself a cookie. Very well done. So it appears that the sine of half pi is 1. The cosine of a quarter times pi is 0.707 and a bit. And we've printed that the log of e to the power of 2 is 2, and the square root of 16 is 4. And the greatest common denominator of 60 and 44 is 4. So this is just to show different ways of formatting your results and of calling functions as well in Python. In this case, from the math library, but of course this goes for all functions from all modules in Python. Yeah. Okay. Next example, and in this example, I'm going to do something fun, and I am going to start working with subprocesses in Python. So there's multiple ways to do it, but yeah. So if we look at the main function here, I've put some code in here to run a couple of subcommands. So one thing is echo hello world. We will ask the shell to print hello world, basically. So that's what this does. Then I have a separate start method in which I will be executing a ping command to ping the Google name server. And I will then print the result code of that operation. And for the ping command, actually, I'm going to do something special. So I could use this system function, but instead I'm going to use the subprocess module. And the subprocess Python module is a lot more powerful than just using the system function. And it allows us to actually capture the output of the process, for instance. That is one of the nice things that it can do. So if we run this, so we see the hello world. This is where I asked the shell to echo hello world. And then we see here the result from calling the ping process. As you can see, this is formatted a bit weirdly with a kind of B starting off, and what that means is Python is telling us actually this is a byte array, not a true string. So if we look at the code here, we have the result.standard outputs. So we've printed that, and that is basically a byte array and not a string. So if we actually want to have a string, which we might want to do for various reasons, then what we have to do is we have to call the decode method on there and specify what encoding we want. So in this case, I've guessed, or I've told Python that we are using the UTF-8 encoding. And so it will use that to convert the byte array into a Python string. And then finally, this function returns the result code of the command. So if we cause the command to fail for some reason by providing an invalid input, for instance, then we see okay, the result code is 2, and the output is, well, apparently it doesn't produce any output. So yeah, that's another one of the fun things you can do in Python. So a couple of interesting things to note in this example here is I've imported the subprocess module in Python, but I've done that inside the function itself. So normally what you would do is you would always put it at the top of the file. That is kind of the convention, but you don't necessarily have to. So you can also put it inside functions. One of the reasons to do that is the import itself may sometimes be an expensive operation that you don't always want to do right off the bat. So your script starts a bit faster. Another good reason to do it is the module you're trying to import may not be present on all systems. So you might want to only call it after you verified that you are running the script on Windows, for instance. There's a couple of reasons why you might want to do this. In this case, though, I'm only doing it to showcase that it's possible. Please don't do this unless you have a good reason. Right. There is one final thing that I want to show here. So the subprocess module has a run function, and it expects a list or an array, you would say, in C of arguments. And then it has another another parameter that we give it. And so this parameter, we actually specify which parameter we want to give. So this is a keyword parameter. So we could just run it like this, but then we don't really know what parameters we are actually giving. If you write it like this, yeah. So for one thing, it's a lot more clear what you are actually trying to accomplish. So it acts as a kind of self-documenting feature of Python, which is kind of cool. And also, there could be multiple optional parameters like this. And you might decide, okay, I'm not interested in providing the first 6 optional parameters. I only want to provide the 7th one. And this is one way of doing that, is to explicitly specify which parameter you are setting. And every other parameter is basically, every other optional parameter is basically set to the default because we haven't specified it. So that's kind of cool. So I've said that the subprocess run expects a list of arguments. However, we've only provided a string to our function. So I've solved that problem by calling the split function, which if you call the split function on a string, it will split that string into a list of substrings. So it's splitting on every space. So that means it converts this string into a list that looks like this. I can actually show that. So if I comment out this code, I can write this instead, and this is basically equivalent. So I can execute it again, and yeah, you see it's the same result. So this is how you specify a list in Python. For this particular kind of list, we use square brackets and commas to separate the elements from each other. Okay. Of course, if we hard code it like that, the code is a lot less flexible. So we try to avoid that. And we can do that this way by just splitting the input string like that. Okay. And that's it for this example. So feel free to experiment with it a bit on your own and let me know what you think. Are there any questions so far?
Yeah, can you remind why did you have to split?
Right, I have to split because I can't pass command to subprocess run like this. Subprocess.run actually expects an array of parameters. It doesn't, yeah, so I can show that actually. If I try to pass a string here, then it will say file not found error because it tries to, it thinks that the entire command is just a file name if I do that. So really we need to give multiple separate values here. So we need to give a list of arguments to that function. So it's and if you want to know how I know this, right? So do I have some arcane knowledge? Well, you can look it up on the internet, of course, but Python has another very useful tool. I can just load up the console, import the module, and what I can then do is say, I know there is this function called subprocess.run, I believe it's called. What can you tell me about it? So I can call help on that, and it'll give me the basic details of the function. So here you can figure out, okay, there is a capture output optional parameter that is false by default, for instance, and it gives you a whole bunch of explanation here. So yeah, this function actually is quite powerful. It allows you to do a lot of things with standard input, standard output, standard error of a process. Yeah, and yeah, so if you are ever in doubt, then just using this help in the console is a quick way to learn more about it. In this case, it's a bit of a bad example, however, because it says here the other arguments are the same as for the popen constructor. So it's actually referring us to a different function called popen. And this function here expects a bunch of arguments as a list. Yeah, a string or a sequence of program arguments, but if you give a string, then it thinks that string is just path to a file. So yes, this is one way of figuring out how to do it. Of course, the documentation online is a lot more extensive, and so it's recommended if you are in doubt to just Google it, how to do it. Right.
Okay, thanks.
Any other questions? Okay.
Yeah, I'm sorry, I have a question.
Yeah,
You wrote import subprocess as part of the function. So it's okay to write like this, or we should write everything about import as above in the header?
Yeah. So like I said, it's usually not okay to do this. I'm only doing it here to show you that it's a possibility. And you may notice it in other code, but 99% or 97% of cases, let's say, you always want to put the imports here at the top. The reason why you might want to do it differently is for instance, if you have certain modules that only exist on Windows, or you're using a different module on Windows and on Linux, or the module you're loading is very heavy, so it takes a while, and you want the script to start up immediately without any delay, or things like that. So those are some of the reasons why you might want to do it differently. But usually, yeah, always, in case of doubt, always put it at the top of the file.
Oh, thank you.
Yeah, you're welcome. I think there was one more question that I saw in chat from Moran. Yeah, so I've addressed that one, I think. Yeah, so we can't pass a single string to subprocess.run because the function is not written that way. Okay. Okay, moving on to the next example. This is an example where we play a bit with lists in Python, and with for loops and with the range keyword. So yeah, a range in Python is a command that generates. What it generates is actually an object that generates the numbers 0 to 4 in this case. So to whatever the argument is. So range 6 will generate a generator that generates the numbers 0 to 5. Range 4 generates a generator that gives you the numbers 0 to 3 and so on. So if we just take a look at this code here, I can actually just paste it in console here. So I can do something like for index in range 4, print index. Then you can see it prints the numbers 0, 1, 2, 3. So that function can be useful to generate lists in all kinds of expressions. And you can also use another argument. So you can specify not just the end, but the start and the end. So like this, I generate all of the numbers from 4 to 9. So it's always the last number is not included in Python. You see that a lot. So the first number is always included, but the last one isn't in these kind of expressions. Next thing, I've made a list here of a couple of numbers, 4 numbers. So I can print them like this, or I can print them in a loop. And so we can use this loop, this for loop here, for index in range 4 to just print all of the numbers in the list. So let's try that. So we can just put the numbers in here, copy these lines here also in the interpreter. And we see, okay, now we are printing each number in the list. Okay, that's all very well and good, except we've hard-coded the number 4 here. So we are basically hard-coding the amount of numbers in our list, and that's no good. So we can change it a bit and just use the len function, which this gives you the amount of elements in a list. So if you do it like this, then you get the exact same result, but you don't have to hard-code the size of the list. So if the list size changes, then that code will still work. Of course, that's for people who know Python, that's a bit of a roundabout way of doing it, because you can just iterate over a list like this. So you can write for number in numbers. So for each element in your list, print that element. So that's a much cleaner way of writing it, like this. So that's a lot more elegant, and that's how it's usually done. But I want to show this way of doing it as well, because it will be useful in some cases. So as you can see here, we index a list using square brackets. So if you want the first element of the numbers array, then you have to do numbers, square brackets, and then 0, or a variable that is 0. And the same for the second element with the number 1. The third element is number 2. The fourth element is number 3. And you can change elements at a later time, also using the same kind of straight bracket indexing. Of course, we can have lists of other things than just numbers. So you can have a list of strings here. So here I've written a number of questions. What is your name? What is your quest? And what is your favorite color? So we can go over these questions and maybe get some answers from the user. So let's give that a try, actually. That's example number 6. So, what is your name? My name is Frederik. And then the script says you answered Frederik. Yay. What is your quest? To teach people about Python. What is your favorite color? Red. And I can pass, apparently. Okay, so how I did it is I did it using a for loop where we go over each of the questions. So for question in questions, that means each iteration in the for loop, we assign a different element of this list to the variable question. And And so the first time around, we print the first question. The second time around, we will be printing the second question. The third time through the loop, we will be printing the final question. And then the loop will finish. And each time, what I do is I use a function here, sys.standardInput.readLine. So this is how you get input from the console. You import sys, and then you have a number of objects in sys for standard input, standard output, and standard error. So in this case, I'm selecting the standard input variable, and I'm calling the readLine function on that. And it will read an entire line at once from the console. So it will wait until the user presses enter before you get the result. And yeah, if we tried it in a console, so actually, yeah, actually I have to use Python 3 because my system defaults to Python 2. So that's also something to watch out for. Python 2 is still quite common, but we are using Python version 3 for all of these examples. Anyway, I import sys, and then I can do sys.standardInput.readLine. And then the console is blocked, as you can see. So I can just type here something like testing, and then I hit enter, and then you get the result. And this is the result of the operation here, is the string testing with a new line character in it as well. So oftentimes you don't want a new line character, so you can use the strip function that I used here to get rid of the new line. So that's another very interesting thing. If I have a string with lots of new line in it, and I call strip on it, you just get all of the new line removed from the string from both sides. So that's very useful. So, so yes, so we get the input from the user, and then we call strip to remove the new line, and then we show the answer in this print statement here. You answered this thing that we just got through readLine. So that's this example. Any questions? So Moran, yeah, Moran, that's a very interesting question. So you're saying that it seems ranges using a lot of memory allocates a list of numbers in range. Range 1 million will use 1 megabyte. Does a more memory efficient alternative exist? That is actually one of the interesting differences between Python 2 and Python 3. So if I just start Python 2 and I get a list of range 10, and I look at the type is list. So I can see here you have a list of 10 items, and if I do range 1 million, then it will be a list of 1 million items. That's a lot. In Python 3, if I try this, so x is range 10, and then I try to see what is x, what kind of type is it? It's not a list, it is a class range. So if we look at it, it just says a range from 0 to 10. And so this thing here is not actually a list, it is a generator. It generates the numbers as required. So it doesn't allocate an array like the old version used to do. It's yeah. So if you actually want an array, then or a list, I should say, then you have to use the list function on it. and if you use the list function on the generator, then and only then do you actually get the list. However, if you just step over it like this, at no point does that actually generate or allocate the whole list. So that's pretty cool, I think. I hope that answers your question, Moran. Okay, are there any other questions? You can also just talk to share your questions. Yeah. So yes, the range was actually an issue previously in Python that allocated so much memory. So that's why they fixed it in Python version 3. Or fixed, they changed the behavior, let's say. Okay, so then I have a kind of an addendum to this to talk about the various collections that exist in Python. So we've already talked a bit about the list, but there is also tuple and dict. So let's just go over the 3 of them and see what the differences are. And I have to say that this is not all of the containers in Python. There are a couple of others as well in the standard library, but they are not like absolute key. You have to import a module to get them, and so they are not quite vital, but they can be handy in some situations, like named tuple, for instance. There's dec, there's default dict. I'm sure there's others that I missed. So there's a number of different containers in Python, but these 3 are kind of the basis, the crucial ones that almost every Python program uses. So let's start with the tuple. So tuple is basically just a collection of values. So it's a kind of list, but it is absolutely read-only. You can't add to a tuple. You can't change elements of a tuple. The syntax for defining a tuple is using round brackets and commas between the elements. However, the round brackets here are actually optional. So you can also leave them out, like I've done here in the second example. You can just leave out the round brackets. And you can, and if you want to show a certain element of that, so you want to index a tuple, then the syntax is exactly the same as for lists. So you do use the square brackets to index a tuple. There's another cool property of a tuple, and that is you can unpack them. So I have here my tuple with values 1, 2, and 3 in them. And I can write code like this: A, B, C equals my tuple. And what that will do is it will allocate the value 1 to the variable A, the value 2 to variable B, and the value 3 to variable C. So it will basically, one way to look at it is you have a tuple on both sides of the equals sign, and so you assign from each corresponding element, basically, between 2 tuples. This is another example of doing that. So we have a tuple here that I've just defined in code. And we are unpacking it here. So we assign, so the first element gets assigned to variable D, the second to variable E, the third to variable F. And then we have an underscore. And the underscore means basically ignore or discard this value. So we don't care about the 4th element. We don't want to assign it to anything. So we just put an underscore here in place of an actual variable name. So yeah, that's pretty cool. And yeah, that's it for the explanation about how tuples work. Except yeah, you have to bear into mind that tuples are read-only, so you can't do something like this. My tuple 0 equals 0. If you try, Python will complain. So we can paste some code in the interpreter again to show that. So we can just, for instance, print my tuple 1. But if we then say my tuple 0, let's give it another value. Tuple object does not support item assignment. So that's something to keep in mind. Also, even if you have an object, like a complex object inside of a tuple, you can't necessarily change that object when it's inside the tuple. Right. And you also can't grow the tuple or remove elements from it. So once you define it, basically, I am completely mistaken, apparently. Okay, that's embarrassing. Apparently, you can grow the tuple like this. So what we've done basically is replace the tuple with another tuple that includes the other right. That includes the other elements, but you can't remove elements from it. You can't, and yeah. So you can do that with lists. So that's so lists we already saw. So they are.
I have a question.
Yeah, Christina.
Can we put different data types in tuple, like integer and character, in one tuple?
Yes, indeed, good question. So we can experiment with that a bit. So we can have a tuple that includes like an integer, and we can have a string, hello world, and we can even have an array in there. So let's say 1, 2, 3, and that's perfectly valid. Sorry. So we have these values here: 12, hello world, 1, 2, 3, embedded in the tuple. So, but what happens then if you want to change something? Actually, I'm not sure, but yeah. So you can change it like this. So you can change something in the array that's inside the tuple. But if you want to change out the array for a different one, then you can't do that. But yes, you can put anything you like in a tuple. You can put anything you like in a list as well. So you can have a list of strings, a list of numbers and strings mixed together. You can also put objects in there. You can even, yeah, you can put all kinds of things in all of these lists.
Okay, that's cool. Thank you. Also, I want to ask what is good to use tuples for if we can't modify value?
That's a good question. So they are useful if you have a list of constants, for instance. They are useful also as return values, or for just ensuring that something won't change, like you would use const in C++, for instance, in some cases, right?
Okay, I got it. Thank you.
Yeah.
For your answer.
Right. Another interesting thing that you can do with both tuples and lists is you can slice them. So you can say, I want a copy of this tuple, but I only want starting from the second element up to the fourth element. Or you can say, I have this list here, and I want a copy of this list, or yeah, I want a copy of this list, but only start from elements element 2 to element 5. And as I mentioned before, so this last number is not included, right? So if you have a list, so let's show this actually in the interpreter here. So we have a list and we expand it a bit here. So if we look at my list, we have these values here. We can then say, okay, we want to start at index 2, and we want to go up until index 5. It does not actually include the item at index 5. It only, so, yeah. So that's a useful thing to know. If you want the item with index 5, you have to specify from 2 to 6. And you can also use some negative numbers in here. So my list index number -1 is the last element in the list. So if you want the last 2 elements in the list, you can do -2 until, and then leave the second part of that empty. And then you get from the second to last element in the list up until the end of the list, basically. So that's kind of like writing something like this. So it's like writing my list from the length of the list -2 until the end, but a lot shorter. So that's quite useful. And you can also write something like this. So you can say, I want the entire list except not the last 2 elements or the last 3 elements. And then you can write something like that. So these negative indexes can be quite useful to create lists, or yeah. And that works for both tuples and for lists. So that's quite useful. And the next fundamental type that we should see is the dictionary. So a dictionary looks like this. So you have keys and you have values. So in this case, I've chosen to have strings as my keys and numbers as my values, but you can do it also the other way around. The type doesn't really matter. So let's put it in our interpreter so we can play with that a bit. So yeah, so this is what it looks like canonically if you print it out in Python. And yeah, you can index it like this. So print my dicts b. That was okay. So we get 2 because the value in the dictionary in B, for b is 2. If we try to print something that doesn't exist in the dictionary, like f, for instance, we get this key error. So that's a kind of exception in Python, which we will talk about more about exceptions later, and how to deal with them. And if you want to add a new value to the dictionary, you can just do it like this. So you can say, okay, the value for f should be 6 in the future. And then if you print it, then you will see it has been added to the dictionary. Okay. So you can get the keys and the values as a list. So let's take a look at that. So my keys. So this is a list of all of the keys, and the same for the values. So you have a list of the values. So if you only want the keys or you only want the values, you can get them easily. And then you can also get them as a list of tuples. And that looks like this. So you have a list of tuples. So a tuple is, yeah, so that's the read-only kind of list that we discussed earlier. And it will have 2 values, the one that was the key and then the value. And here again, key, value, key, value. And you can also convert, if you already have something like this. So you have this this thing, then you can turn that into a dictionary by using the dict function. So you can convert in both directions. And that is, all of that is quite useful because of how you iterate over a dictionary and how you work with dictionaries in Python. So if you want to go over all of these types in a for loop, for a tuple and a list, it's pretty easy. I already showed it before. So it's for item in the tuple. You can just print the item in the for loop like that. This the exact same for the list. For a dictionary, it's a bit more complicated. If you do for something in a dict, then you get the keys and only the keys. So if you want to print out the entire dictionary, you would do it like this. So for key in my dict, print key and my dict key as arguments here. So so this code here prints out the dictionary. So I have to reference the dictionary again to get the value in the for loop. If we want to avoid doing that, then we can use the items function here. So we can just iterate over the items. And that is quite interesting, I think. So here we have key and value both in the for loop available. And this is just a very interesting way that Python features come together. So I told you about the tuples, how you can unpack them, right? So you can do something like this. A, B, C is my tuple, and you can also do that in a for loop. So you can say for key and value in my dict.items. So this is something that looks like this, a list of tuples. So each item is a tuple, and in the for loop we unpack that tuple into two variables here. And that is a quite common thing to do in Python. It's very useful and just creates a lot shorter and readable code. One way you can see this often is with enumerations. So this this uses the enumerate keyword. So if we, so we have a list here, my list. This is just a normal list. However, if we want to go over the list, we can say for item in my list, print that item. But if you want to print this is item number 1 in the list, and this is item number 2 in the list, you can't really do that in this way. So what you can do is you can use the enumerate function, and if we do that, then you get a tuple of the index and then the value of the list. And this also works for tuples, by the way. So we get a list of tuples here generated by this enumerate. So what we can do is we can say for index and value in enumerate the list, we can say print item number, number, this is this. I forgot to close a statement there, I think. Yeah. Okay, so we see here item number 0 is 55, item number 1 is 2, and so on. So this illustrates a number of interesting principles, like the unpacking of the tuples inside of a for loop to create code that that just looks better. than if you were to write it differently. So you can also do that with going over. The other way to do it would be to do something like for index in range of the length of my list, and then you would say here my list index, but that's just tedious. And once again, I've forgotten. Yeah, this is just tedious to do. So the enumerate thing just looks a lot better. So that's what I usually use. All right. So that's the 3 basic containers of Python. There is actually one other thing in Python that's kind of like a container, and that's the string. So that's another fundamental type. A string, you can write it in a number of different ways in Python. So you can write my string is something in double quotes like this. So my string. And you can actually see here, Python represents this using a single quote. Why is that? Well, actually, it turns out in Python, it doesn't matter if you use single quotes or double quotes. They are exactly equivalent at all times. So whether you use double quotes or single quotes is just a matter of preference. It doesn't affect anything. So you may be wondering, well, especially if you know C, well, how do you represent a single character in Python? And the answer is that Python does not make a difference between a string and a character of, a character and a string of size 1. They are exactly the same in Python. So you could say my character is A, but if you look at type of my character, it's still just a string, and it acts like a string in all cases. So yeah, strings, of course, you can print them. You can also index them in the same way that you can index lists or tuples. So you can print just a couple of characters in the middle of the string. You can print only the end of the string, like this. And you can print a single character in the string, like this. One of the interesting and amusing aspects, actually, is if you do that and you get just a single character out of a string, that character is itself also a string. So you can also get the 0th character out of that, and out of that, and out of that, and so on. So this is still just a, so basically each time I subscript this, I'm just making a copy of a string with that single character in it. So that's pretty cool. And there is also a third way to do things. You can also use these triple quoted versions. So this is another way of declaring a string in Python, a multi-line string. So my long string here is a multi-line string that includes a number of new lines because of the way I've written it. So yeah, so if we actually print that. So yes, if you want to write multi-line strings, long strings, then you can use this syntax, right? And you do have to be a bit careful. If you are in a function, then you will usually be working at an indent. And if you write a string here at an indent, so something like this, so you can do something like this, but you will see the white space here. So yeah, it's easy to forget that, especially if the string you are writing is in line with your code. But if you wouldn't want want that, then you have to write it all the way like this. And that looks a bit ugly. So yeah, that's one thing you have to keep in mind. Okay. So yeah, that's yeah. And also another thing to take into account here. I said in Python that it doesn't matter if you use single or double quotes. Python always treats them the same. And that's also the case here. So you can write it like this as well, using double quotes or using single quotes. And it's exactly the same. Of course, you do have to use the same thing. So if you start the string with a single quote, then you should end it with single quotes. You can't mix and match. But this does mean that if you have a string that includes double quotes, then you can use single quotes for the string, and then you don't have to escape these double quotes in here, because Python won't be looking for double quotes. So this works just fine. Right. If we use single quotes, then that might not be fine. Although in this case, I think it looks for 3 quotes, and you're only giving 1 at a time. So I think that would actually still work fine. I'm actually not sure. So one of the fun things about Python is you can just test it as you go along in the Python interpreter. So if there's anything you don't know or are feeling curious about, then you can just open the Python interpreter and try it out. So you can try something like this, and you see here that we got an error. And yeah, so if I wanted to do this, then I would need to escape it using backslashes. But a much easier thing to do, of course, is to just use the double quotes if you are trying to write something that includes single quotes, and vice versa. So this here, there's no problem at all with that. Okay, and so that also goes for the single quote version. If you have a string that happens to include a single quote, and you don't want things to be difficult with escaping and so on, then just use double quotes for your string. If your string contains double quotes, then just use single quotes. That's the easiest solution. Of course, if you have both, if you have both single and double quotes, then we'll have to escape one of them. So if I choose to use single quotes for my string, then I have to escape all of the single quotes inside of the string with backslashes. Right. Apart from that, it doesn't really matter if you use double or single quotes. Yeah, it's just personal preference in general. There are some conventions, but yeah, just do what feels right. Okay. Are there any questions here? I should also check the chat.
Yeah, I have one. You use the triple quote for defining of the string,
Yeah.
but triple quote it's a commentary, as I understood. Or no?
So you may have seen that I started each example with triple quotes here, and in this case, I'm not assigning this to anything. So it basically it's a value that gets lost. It doesn't get used for anything. So it's kind of like a comment, right? You are defining a variable, but you're not assigning it to anything. It's like writing this in some C or C++ code. It's valid, but it's completely pointless, right? So you can do that in C as well. You can just write, this is a comment, which is just a string inside of your C code, but you don't assign it to any variable. So the compiler, in the case of C or C++, will just throw it away. And so you can kind of use it as comments, except of course that linters and generally don't like it, and also compilers may give warnings that you are not using a value. So this is not a good idea in C or C++, but you could technically do it there as well. So that's a bit more common in Python. To just do this also for comments, to just define a string like that. And one advantage also of these strings is that they can be used for documentation in some cases. So if I write a function here, I'm writing a function called test. And I will put a doc string in here. This function is just to illustrate doc strings. It has no other purpose. Actually, that was a mistake. Hang on. I should actually put something inside the function. Okay, so we have the function test. We can call it, and it outputs test. But now if I do help on that function, we see here the help function. This function is just to illustrate doc strings. It has no other purpose. So if by doing this, you automatically document the function. And one other way to do it is you can even print that string using this syntax: underscore underscore doc underscore underscore. So Python keeps track of that text and as kind of the documentation of the function. So the first bare string that you have in a function or in a module serves as a documentation of that function or of that module. So this is often used to write documentation for a module. And since each Python file is effectively a module, what we can do is import into 06b. What did I call this one? Containers. Okay, so we've imported it, and what import does is it just loads everything. It starts executing everything in the code. So it's executed all of this code. But now we also have the module intro 6b containers. And if I look at the doc string for that, so we have the documentation. It says this example illustrates blah blah blah. So you can print that, then it looks a bit better. So you see here this this string again for the documentation, and you can also use the help function now on the module and get that same documentation again. So here you see it under description. So Python does use that string to document the module in this case, so it doesn't get wasted. Cool, right, Vlad?
Yeah, thank you.
Yeah. Okay. So yes. Moving on to I should check if there are any more questions. Moran asks, when iterating on a container, how to remove elements while iterating. For example, remove from a list all numbers which can be divided by 5. you can do that, but it's a bit complicated. The easiest thing is just to generate a new array, or a new list, I should say, from the previous one. And we will get to how you can do that. One thing that I can show, it's not actually part of the things that I wanted to show, but it can be useful. So you can do something like this. There is the del keyword to remove an element. So if I do del mylist2, and I then look again at my list, you can see that the element that was at index 2 is now gone from the list. So that's one thing that you can do, is you can use this del command, if you like, to remove something from a list. And I believe if you try that on a tuple, so you see tuple, the object doesn't support item deletion. So yes, you can use del to remove an element if that's what you want to do. Copying is often easier. So and for that you can use something called list expressions. So you can say, I want a new list. So I have a square bracket, and you can say item for item in my list, except I only want it if item is not divisible by 5, for instance. And so then we get a new list containing elements 2, 4, and 6. So this is a list comprehension. They are used quite a bit in Python, and I think I have an example of them later on as well. So that's usually how you would do it in Python. Is you have you would do something like this. So you create a new list, mylist2, based on my list, using a list comprehension like this. So that's the more Pythonic way to do it. Of course, it creates a copy, so it's not as performant. You have a point there, but in Python, if you are using Python, you probably aren't quite as concerned with performance anyway, because Python codes as a scripting language will always be less performant than C or C++. So there are iterators and generators in Python, but for some things you would have to write them yourself. Okay. Then Jelly asks, so the only advantage of using a tuple instead of a list is that tuples can be unpacked, which is useful for functional return types. Are there any other advantages to using a tuple as a list? So Jelle, to answer your question, so I consider the fact that tuples are immutable to be an advantage in its own right in some cases. It sends a clear signal that you don't expect this to be modified anymore. So it's just, so for lists of constants, and for things like that, can be quite useful. You could use a regular list for that, but then it might get modified later, and that's something that that often you don't want. And it's also a bit self-documenting, right? If you use tuple instead of a list, then the caller knows, okay, I'm probably not supposed to modify this. Okay. Then next question was, are the elements on the dictionary ordered or unordered? So it's a good question. So I think they are unordered by default. So I still have a dictionary here, right? It does look like it's ordered right now by alphabet. So I don't know. Maybe it is ordered by default now. It used to be unordered, I'm fairly sure. Yeah, it seems to be ordered by key. However, yeah. So it's ordered by default, it seems. Yes, that's the answer. I think there may be an unordered variant of the dict, but I'm not sure. But the default one is ordered, it seems. Okay, moving on to, first of all, are there any other questions? Okay, moving on to the next example. So in this example, I want to illustrate branching a bit more. So we already saw for loops in Python, but now I have an example with some if statements as well, and a while statement. So this code, what it does is it has a list of questions here that it will ask you, but the last question might randomly get replaced by what is the capital of Assyria. And then we go over the questions, we print each question, and we append the answer to a list. So we are growing a list, basically. So we're growing a list, and then we print the answers afterwards. So the list of answers. And if the answer was empty, or if the answer contains the string don't know, then we print, "Arr, you died, better luck next time." And we exit the program. And then what we do is, while not valid, what is the average airspeed of an unladen swallow in kilometers per hour? And we try to get an answer from the user. And if we can parse it as an integer, then we set valid to true. And we see what the speed is. If it's less than 0, we say, what, they fly backwards now? If it's less than 30, we say, seems kind of slow. If it's less than 200, we say, seems legit. And if it's 200 or more, we say, hey, wait, did the swallow actually board a supersonic jet plane or something? So this is how if statements work in Python. So there's no curly brackets like you might be used to from other languages. No, that's not it. You just have a space there. And yeah, so you can chain them together using elif. So that's else if in Python. Yeah, right. Always with different conditions, and then there's the else. And you do have, this is quite important, with all loops actually, not just with all control statements, I should say. So the for loop, the while loop, and the if statement, they all have the semicolon here. So that's also quite important. It lets Python know that the condition has ended. And one thing I'm not demonstrating here is you can combine conditions using and or statements. Like this, and you can use brackets to group the conditions in the same way as you would in C or C++ or other languages. So these are if statements in Python. So let's run this. So my name is Frederik. My quest is to teach Python. Oh, what's the capital of Assyria? I think it's Damascus. And then the average airspeed of an unladen swallow, 20. Kind of slow. Okay, so yeah, that's how it goes. I've written in here a couple of alternative ways to do it. So the answers array, I am populating it in the for loop using plus equals. And that's basically the same as the first thing, right? So you can say the answers list is the answers list plus a list of that contains just the single answer that we got right now. So the plus equals is basically doing the same thing, but is a shorter way of writing the same thing. And what you can also do is use the append function on a list with the single answer. So which one of these two you use kind of depends on taste. Personally, I prefer this one, but you can also just use this one. And I'm sure that there are other ways to do it as well. Another thing to note here is I'm writing here in the condition while not valid. You could also write while valid is false, while valid is not true, while valid is false. So you can use the is keyword instead of the equal signs. You could write while valid is not true using the words is and not. You could write while valid is not false, and so on. So there's multiple ways to write this. But it is generally recommended to use the not keyword rather than to write it like this, while valid or while not valid. Comparing with false or true is generally not a good idea. And also the is not really a good idea here in general. I can't really get into the reasons why, because we still have a lot to cover and I can't cover everything. So I'm going through this a bit faster. However, we do still have time for some questions if there are any.
Yeah, I have one. It's string 77. So what does it mean? Like name equal to main, how it works?
That's a good question. Right, so previously in the examples I've written here, everything in the main function. And then here I'm calling the main function, right? That is good, it splits up the implementation. But it still has a problem if and you can see it if I start an interpreter and I import intro 04 math, it automatically executes all of the code here because the function invocation is just written right here. So every time this code gets imported, the function gets executed. I don't necessarily want that. I want code that you can run on its own, or that you can import from somewhere else as well. So code that can do both things. In this case, I can actually do that. But every time I import it, it would always immediately run this function. In some cases, you might not want that. In a lot of cases, actually. So what's different here is we have this extra condition here, if name is main. So what happens if I import this function here? Import intro 07 flow. Nothing gets executed, actually. The main function was not executed because, so this is a good trick. The name variable is automatically set by Python. So you can tell that it's a reserved variable because it has underscores on both sides. Those generally mean that Python has assigned special meaning to something. And in this case, the reason is it's Python is setting this variable itself. So if you execute the script directly, it sets the name variable to main. If you don't call it directly, I don't know, it's either not set or it's set to a different value. I'm actually quite curious about that. So I guess we can test it. So if we yeah, so it's probably not set in that case. Right. So if I want to actually call this, then I would have to manually specify I have to call main. So so yeah, that's the reason for that. Good question, Vladislav.
Yeah, and I have another one. So first of all, you imported the fourth example, and after that the seven example, and means the main, if you call main function, it will call from second import or from first import.
That's another good question. So and you can actually see it here still on screen. So I imported intro 7 flow, and then to call the main function, I have to call intro 7 flow.main. So if I import 4 and I want to call the main function a second time, I would have to call intro 4 flow intro 4 math, it would be dot main. So yeah, the package itself that you import is its own namespace, basically, right? So it automatically executes once because we didn't have the if statement in example 4. But if we want to call it again, we have to use this syntax here to specify that it's the main function from intro 4 math. But that also brings us to another point. I have here a special import statement here that's new. So what you can do is, instead of saying import random and then calling random.random here, what I've done is I've just said from the random module, import the random function. And that way I can just call the random function directly. I don't have to say random.random. So that's another way of importing things. So what I can do instead, if I was lazy, is I could say from intro 7 flow import main, and then you can just call main like this, and Python knows, okay, main here is imported from this module, so use the main from that module. If you try to do that from multiple modules, then it should fail. But yeah, in this case, it's wait. Or actually, does it override it? Let's see. Yeah, I think it overrides it if you do it multiple times. So the last import statement is actually the one that counts. Okay, Vlad?
Yeah, thank you.
Okay. So we move on to the next example, which is exciting because it's the first one where we actually define a class. So I've written here a class image, which I've documented as a 2-dimensional pixel container. You provide the pixels yourself to the constructor. So this is what a constructor looks like in Python. It's once again, it's a function that starts with 2 underscores and ends with 2 underscores, which in Python just means that it has a special significance to the Python interpreter. And in this case, the significance is that Python will automatically call it to construct the objects. All member functions in Python have a first parameter called self. And this is equivalent to this in C++ or in Java. Except in Python, you always have to specify it in the function declaration. It's not hidden for you like it is in C++. And if you want to set a member variable, it's not enough to say m pixels is pixels or something like that. No, you set it on the self object. So each member variable in Python, you set it on the self object. So the self object is quite important to pass in. Yeah. So that is quite different in Python to what you might be used to. Right. So I've defined a number of functions here in this example as well that are quite interesting. So I've defined a function to return the width of the image and the height of the image. And as you can see, they are just looking at the length of the pixels array that's passed in, which is supposed to be a two-dimensional array that you pass in. And then there is a getPixel and a setPixel method. And it does some basic checks to make sure that the value that you pass in is not too big. And actually, I made a mistake here. Right. Okay. So it has a basic check in here, and then it just returns the value in the array. And for the setPixel, it also has a basic check. And if the check passes, then you set the pixel at that coordinate to the value that's passed in. However, there's a couple of new things in here. So first of all, we see here, we have raise index error. So this is a way of creating an exception, or raising an exception in Python. So index error is a type of exception. Right, there are multiple types. In general, it doesn't really matter too much which one you use, but there's a couple of built-in ones that can be useful, like index error is pretty useful here because basically if the check was allowed to go through, you would basically index an element out of bounds, which is what index error represents. So I thought that this exception clause was from base Python was useful. If you don't have a useful exception to throw, you can just either throw exception itself, or you can define an exception class that's derived from it yourself, and then raise that. So this is how you throw an exception in Python: raise and then exception. And this is how you catch it. So we have a try statement here, and an except here, which is the equivalent of a catch in C++. So that's a nice thing to look at. Right. So yeah, as usual, I've used docstrings here to provide a bit of documentation to the method as well. So if you load this up in the Python interpreter, you can use help to print the documentation and get help on that particular member function. So the rest of the code, the main function, what it does is it finds a number of pixels, gives it to the image. So you can see this is an array that contains 3 arrays here. So the height is 3 and the width is 4 of our example image. So here we're just imagining that these numbers actually correspond with pixels. But this is just in our imagination, of course. We could put pixel objects in there or whatever, but right now we're just working with numbers. we initialize the image. We call a couple of functions. We can get pixel values with the getPixel function. We can set them using the setPixel function. One interesting thing to notice here is in the definition of setPixel, you see we have 1, 2, 3, 4 arguments, including the self object. But if we actually call it, we don't pass in the object again, right? So here you only have 3 arguments instead of the 4 here. The 4th is taken, of course, from the object that you call it. So in a way, this is Python uses some syntactic sugar to call. Yeah, you could look at it like that. Another thing that's a bit strange here is I've put an int here. So in Python, you can now, this is also a new feature, you can hint at what kind of value you want. So that's mainly used for documentation. I don't think it's actually enforced, but you can document and you can say, for the value here, I want you to pass in an integer and not a float or an object or a string or anything else. Like I said, though, it's not enforced, I believe. So if you want to actually enforce it, you have to explicitly check for that yourself in Python. A lot of code in Python just assumes that the types will be okay and doesn't really treat them that seriously. You can do that yourself. You can have explicit checks in there, but since Python is often used just for quick scripts, it often doesn't really make sense to do that. So we just take by faith here that all of the parameters will have the correct types that we expect. Right. In our try except block, so the except is like a catch in C++, you can see we have a special syntax here. We see here that we are expecting a possible index error, and we are and so if there is an index error, then we print it out. If you throw some other error, then the exception would bubble through, and it would actually exit the main function prematurely and cause the program to fail because we are not catching that exception anywhere. Okay. So any questions so far? So Moran, you asked, is there an option to pass arguments to a function by reference? Yes, you can do that. So in here, for the getPixel, I've just put 1, 1. But what you can also do is x is 1, y is 1. It's that simple. And if you do that, then actually the order no longer matters, and you can write them in the opposite order as well. By reference, sorry, I thought you meant, by name, sorry. Yeah, by reference, it's a, yeah, I guess you could wrap them, but so for primitive types like integers and strings, I think you are probably going to create a copy for, each time. And objects are, I believe, passed by reference. So if you pass an object to a function, then it will actually be passing a reference. And so if you don't want that, then you have to explicitly copy the object. But for integers and floats and strings, you are always copying those. When you call a function. Okay, any other questions? Yeah, I guess the string could be very long. However, strings in Python are also kind of, they are read-only. So all methods like substrings or things like that, they actually create a new string. So actually what Python does is it doesn't actually copy strings. It does pass them by reference, and they are basically, since they are basically immutable, it can do that. And any operation that changes a string actually creates a substring or creates another string. So there are no issues with that. So strings are actually passed by reference in a way, yes. So yeah, so actually what I said before was wrong. It's just integers and floats and things like that that are Booleans as well, that are passed by copy. Everything else is actually passed by reference, I guess. Okay. So we are unfortunately at our time limit. So I'm going to skip the next example and just go over briefly with the last one for anyone that's interested. So I do encourage you to look at these examples in more detail and play with them a bit by yourself. And that way you will learn a lot more about them. I am just going through this rather quickly. So if there's any unanswered questions here, just play with it a bit, play with the Python interpreter, paste some code in there, see what it does. And I'm sure that you will find all of the answers to your questions that way. For the final thing that I wanted to impart here, I wanted to create a program that does something fun. And this program, what it will do is it will download the comic automatically from the webcomic XKCD. So we will be using several things that we have learned in order to do that. So if we take a look at the, so first of all, what you do if you want to do something like that is you look, is there an API for this kind of thing? Is there an API which we can use to download something from XKCD? And it turns out that there is. So if you want to fetch comics and metadata automatically, you can use a Json interface. Okay, so there is a Json interface that returns some JSON data related to the last XKCD comic that has been posted. So if we take a look at the XKCD in question, let's take a look. This is what it looks like on the official XKCD website. So this is the latest comic that they have. Of course, what we don't want to do in our Python script is scrape the entire website, all of the HTML, and extract just the parts that we are interested in, because that's not very, that doesn't scale very well. If they change their websites, it will break our script, and so on. We don't want to do that. We want to use the official API, and we want to use this JSON, which is a lot easier to parse than HTML. So let's try to do that in Python. So first of all, we need to download the JSON. That's the first step. We need to download the JSON in Python, and then we want to parse the JSON in Python so that we have it as a normal dictionary. And once we have that, then we can extract the title from it, from the image, and we can extract the alt text from it, which we can also display. And we can get the link to the image. And then finally, as a last step, what we do is we download the image. And we can then show that image on on our own computer. And then at that point, we have created an XKCD viewer up ourselves. So that's the plan. And here's the code. It's intro 10 XKCD by. In order to download something, I'm using the requests library. Requests has a simple method called get, and that sends out an HTTP GET request and gets the reply automatically. And so in this entire line, what we are doing is we are fetching a certain URL, composing an HTTP request, a valid HTTP request to download that with the correct headers filled in. The request library does all of that behind the scene, and what it also does is that it then sends that request, waits for the reply, and returns a reply object to us. So we can see here it has an OK variable. If it's not OK, then what I've done and chosen to do in this case is just raise an exception. If it fails, then it fails. I'm not going to try to work around it. And the program stops in that case. The request library also has a JSON method. And what that does is it takes a look at the contents of the request. It tries to parse it as JSON and returns that as a dictionary. So in just 2 lines here, this line and that line, we get the JSON file that we were looking at before. We get this JSON line as a Python dictionary. So all of that functionality that's already done for us. So then the next step is we want to get some information out of the dictionary. So we want to get the number of the comic, the title, the alt text from the comic, and we can also get the date of the comic because why not? And that's what I do here. So I got the JSON out of the request, got all of the data, then I'm printing all of the data. And then what we can do is we can do another GET request to get the actual image. So if we take a look here in the JSON file, we see here image and then a URL, and it's that URL that we need. So this is also going to be a field in the Python dictionary. So in order to get that image, what we do is we send a GET request using the data that we have, and using the image key, we can get the URL to the actual image. And once again, we check if it was okay. So there are other ways to do it, but this is the easiest one. And then what I do is I download the image to a temporary file and run the display command on that image. What I do then is I print pref next or exit. I read the input, and if you press P, then it will decrease the number that we just fetched, and it will go through the loop again. Except this time, the current comic URL is changed, and it will include the number of the comic. So the current number, I believe, is 2382. So if we look at XKCD, I believe, right? So we have the same JSON info here. If we want to go to the previous comic, the information for that, we have it here. So the comic 2381. was one about the toe name of the bear. So that's how we get the information of the previous comic. It's just number -1. And so for the next comic, if you hit n, then you do number +1, and we try to fetch that one. All through the official JSON API of the XKCD website. And so now I get to show you what that looks like. So here we go. This is the current comic as displayed by the display command. And this is the information about it. Okay. I have to then quit the display command, and then I get here the prompt pref next or exit. So I can look at the previous comic. And this is the previous comic. I can quit that again and look at the one before that. Right. Okay. And I can then go in the other direction again, next. Okay. Quit that. And then you can just hit X for exit, and we exit the program. So that's just an example of doing something useful with what we've learned here. So there's a couple of new things that I want to highlight. One thing is temp_file.name temporary file. So Python includes a lot of useful functionality in its standard library. Dealing with temporary files is one of those. So you can get just a temporary file created in here, and when you execute this function, what it does is it will create a temporary file that's automatically deleted when it is closed. And that temporary file, it will have a path on the file system. What we can then do after we've created that is that we can write the data to the content that we've downloaded here. So we've downloaded the content here, download.content. We can just write that to our temporary file, flush the temporary file, and then we can say, hey, display, this display command, let's run you, and I give the temporary file name that we saved the comic to as an argument. So this is just 4 lines, but they do a lot. One thing that I also don't think I've explained yet is the with statement. So what with does is it's basically the same as writing comic is. Let me just copy it. It's like writing comic is that thing, and then actually it's like writing try, and finally comic.close. So it's a way of ensuring that it will always get closed, the resource that you open. So that's another useful Python feature here that I wanted to kind of show off once. So yeah. Yeah. Any questions here? Vladislav, you have your hand raised in the chat, I see.
No, I don't have questions. Thanks.
Okay. Yeah. So, yeah. Something else that I've done here is I've parsed the date. Actually, that was in the comic in 3 different fields. And I've given that to the constructor for datetime.date. So this is a date object that exists in the standard library and that you can use for date and time calculations. So Python also makes those rather easy, which is something that I'm sure you may very well appreciate in the future if you ever have to work with that. It's a lot more intuitive than the APIs in C and C++, in my opinion. Okay. Another thing that is interesting here is I've used this condition here, while key not in capital P, lowercase p, n, lowercase n, uppercase x, or lowercase x. So the in and not in keywords is another useful way of just scanning strings and lists sometimes. So you can easily see if certain thing that you have is present in a certain array, or if you just want to check if something is one of 3, 4, 5, or 6 different options, then this is also a very useful construct to use, the in or not in constructs. So basically, if you give anything else here, then the while loop will automatically terminate. Okay. Actually, no, it's the other way around. If you give p, n, or x, then the while loop will terminate. Otherwise, it will keep going. Right. Okay. So I hope that this was helpful. We have to stop it here, though. So if there are any remaining questions about any of the examples, please let me know right now. Otherwise, you will have to do it later on in Slack or something. Okay. So I hope with this you have a good first taste of Python, and that it's that you learned a lot from it. One of the things, though, with learning a new programming language is, or any language in general even, is you are only really going to understand it and learn how to work with it by practicing a lot. So that's also part of the reason why I shared these examples with you and why I wanted to work with examples. They are just supposed to give you a taste of what's possible. They are not, by no means perfect. You can improve on them, you can play with them, and that's kind of the goal here. So please have fun, and I hope that you will keep practicing. And yeah, there is a lot of ground also that I didn't cover. Do be sure to check out the official Python documentation. So there's 2 things that you can do. So I already showed off the Python documentation that's just built into Python, which you can just for any function that you have in Python and you are not quite sure how it works, you can use the help function to do that and get a bit of a hint. There is also help on the modules themselves, so that can help you. If you are not sure which functions there are actually in a module, you can use the diff function to find out. That's another useful thing to know. So here we see that in the OS module, apparently there is a function called waitPID. Oh, might be interesting for a problem that I have right now. I don't know. Let's find out more about it. So then once you've done the diff, maybe to find our command, then we can get some help on it. And that's just a very useful way to rapidly get the information that you want is to see what's available and then get some more information through help about what various functions do that look promising. And then you can decide if it's what you want or not. But of course, the best documentation is online. So if you really want documentation on Python, copy a file, how to do that, then best to always just Google it. There's tons of information online, just about everywhere. Also, there is official documentation for the official modules. So if you search for things like that, then you will find a lot of information here about various methods in just the Python documentation itself. It's a very useful reference as well. You can even select the version of the language that you want information for. Yeah. Any questions?